The next thing we're going to discuss is some financial mathematics, and we're going to see some savings models, some borrowing models, and we will look a little bit at some exponential growth as well. But first, we're going to look at some savings models. Now, so the way savings models work, we have an amount of money we deposit, and it could accumulate some interest. And we'll look at a couple different kinds of interest. We'll look at simple interest, and then we'll look at compounding interest. First, we're going to look at simple interest, but to do that, we're going to need a couple definitions first. So definition. The principal with an AL, is the initial balance in an account. And we'll largely be interpreting principal as you deposit something, you know, on day one, and that'll turn into the initial balance. But that could be spoken more generally about as just any initial balance. Simple interest is interest that is paid on the original principal only. So we deposit something, and then that amount will earn us some money based on certain interest rates. Now that's going to differ from compounding interest, which we'll study next, in that say you earn 1% a month, and you put $1,000 in. Well, after a month, you're going to have $1,010. Simple interest would say in month 2, you're not going to earn on that 1,010. You're just going to earn on that 1,000. Compounding interest would say you're going to earn on that $1,010, not just the 1,000. With compounding interest, you earn also on the interest that you've accumulated. With simple interest, the interest is paid on the original principal only. And let's look at an example, and we're going to use this example to try to come up with a formula. So let's take this example. Suppose you deposit $1,000 in an account that pays interest at 10% annually. So 10% per year. The units on our interest rate are going to be very significant. So here it's 10% per year. And the question will be, how much is in the account after 3 years? So right here, I don't say simple interest. And if the word simple is not there, it is assumed simple interest. But I could have said that pays simple interest. If it's not simple interest, it'll say something about how it's compounding. More on that in either the next video or later this one. I'm not sure if I'm going to make 2 videos. But how much is in the account after 3 years? Well, let's look at after 1 year. Well, what happens in 1 year? Well, how much interest is there? Well, we earn after 1 year 10% of $1,000. 10% of $1,000, 1,000 divided by 10. So we earn $100 in interest after 1 year. So how much is in the account? Well, we have the original 1,000 plus the 100 in interest. Now, so this says after 1 year we have $1,100. This is just simple interest. So with simple interest, this amount that we get for the first year is also going to be the amount we get for the second year, because in year 2, we're earning interest on only the principal, on only the original $1,000. So each year we're going to get another $100. Let's look more at where we got that 100. So 10%, it's a convenient number because, 10% you just get by dividing by 10. But how mathematically could we arrive at that $100? So maybe I'll just draw an arrow like that. How did we arrive at that? Well, we took this interest rate, converted to a decimal, or a fraction, but here I'll say decimal. We took the interest rate, converted it to a decimal, so 10% is 0.1, and we multiplied it by 1,000. So we are taking our interest rate and multiplying it by our principal to give us our interest. So let's keep that in mind when we're figuring this out after 3 years. So after 3 years, how much interest is earned? So I'll block it off like this into 2 sections. Interest earned. How much interest is earned? Well, we take this $100, but mathematically we arrived at that $100. Which order do I want to put this in? Yeah, okay. That's not the order I wrote it in my notes or what the book is using. Well, I'll just, okay. I want to write the 1,000 first because that's the way the formula is written in the book. So how much interest is earned? Per year, it's 1,000 times 0.1. But how many years is it earning this interest? 3 years. So right here, we have that the interest earned is 1,000 times 10% times 3 years, because it's $1,000 times 10% per year for 3 years. And this equals $300. So that's the interest earned. So in the account, after 3 years, is the original 1,000 plus the 300 in interest, so $1,300. So let's generalize this and introduce some variables so that we can get a formula. I'm going to go to the next page, but the formula at the bottom of that first page, we are going to use that to get to our formula. Okay. So let's call this simple interest formula. And we're going to need some variables. So let's say for principal P at interest rate R. So here in the first one, we had years, but I'm just going to say it's an interest rate with a given, time period. So, it could be like months, it could be an interest rate per day or per year. But, in general, if we keep track of our units, the rate units and the time units we want them to match up. So for principal P at interest rate R, the interest earned in T time periods is, we'll call it I, maybe I should say the interest I earned, but that's fine. The interest earned is I equals PRT. And the total amount A accumulated in the account after T time periods is the original, so A equals the original P plus the interest earned, which equals P plus P times RT. And that last equation, so in on the previous page, I wrote the last thing 1,000 plus 300, and that separated it into P plus the interest, so P plus PRT. But in general, this formula does simplify a little. because notice both of those terms do have a P. So we have P times 1 plus RT. I'm just going to note here. Note the time units. That's not the word units. UNITS. In R and T must be the same. If the units aren't the same, then it's not going to multiply out properly. So let's just look at an example with two parts using this formula. So I might, let me read the example. Find the interest earned after 1 month on that. Okay, so the first example is just going to ask about the interest, but then we're going to ask for the total in an account. I'm going to go to a new page. Okay. Example. Find the interest earned after 1 month on $10,000 deposited at an annual interest rate, simple interest rate of 6.49%. And with all of these, calculators are fine. Almost all of our questions are going to have inconvenient decimals. That's fine. But what is an issue here is notice it says find the interest earned after 1 month with an annual interest rate. So we're going to have to do something to get these units to match up. So you could play with the rate. I think it's easier to convert the time into years. I kind of see that better. They would work out the same, of course. You can divide either one by 12, but I am gonna write the time in years. But remember, I equals P times RT. What's P? P is $10,000. What's R? We're gonna keep it in years. So the annual interest rate is 0.0649. And what is our time T in years? Well, 1 month converted into years is 1/12 of a year. Unit conversions, 1 month times what? 1 year over 12 months. Months cancel, you get 1/12. And this equals, what does this equal? 54.08, $54.08. And we'll ask a second follow-up question here. So that's the interest in what? 1 month? Or in 1 month. How much is in the account after 47 months? So the first question just asked about interest, and we found interest. The second one is asking how much is in the account. So we're going to use our amount in the account formula, P times 1 plus RT. And again, we're going to have to keep track of our time units. What's P? P is 10,000. What's 1? 1 is 1. What's R? We have what? 0.0649. So again, I'm going to keep it in years. So the interest rate is in the annual interest rate, but now we need 47 months. Well, in 47 months, well, how do we convert that to years? Well, 47 months converted into years, 47 months times 1 year over 12 months. So we have 47 twelfths. So keeping the units in R and T consistent is very important. And so we could say approximately equal. Since this is like money in an account, I'll just say exactly equal, and then I'll round it to the nearest cent. And what does this equal? 12,541.92 cents. So simple interest. I always think the hardest thing with these types of problems is being sure I'm organizing the units properly. But next, we're going to look at compounding interest.